Alright, so once you've got your magnet board activity opened up in Notability, I printed it out just so it's easier for me to show you what's going on. What you need to do this activity is your periodic table, and you need a board with magnets. It will have 6 of each color. So what we decided to represent each subatomic particle, protons are red, you can see there's a little P+, electrons are blue, neutrons are green. So the activity, it also tells you that, okay, right here. What color is each subatomic particle? So it's going to ask us to build the following atoms, starting with hydrogen and then going up to carbon. So how do I do this? Alright, so look at hydrogen. Hydrogen is atomic number 1. The atomic number tells you the number of protons and the number of electrons. Okay? If you look at the mass, which is this number right here, it's 1.00094. So if we round that to a whole number, its mass is 1. So I know that it has 1 proton and 1 electron because the atomic number will tell us that it has 1 proton and 1 electron because protons are positive, electrons are negative, and we want our atoms to be neutral. 1 positive, 1 negative. So since the mass is 1, you have to subtract the mass minus the number of protons to get neutrons. So 1 minus 1 is 0. So hydrogen just has 1 proton and 1 electron. So you can write that on your paper. For P, 1, E, 1, N, 0, mass, 1. So remember, you round the mass to the nearest whole number. Alright, so next we have helium. Helium is number 2. Okay? So if you're following along with your periodic tables, this will make it a lot easier. Alright, so the easy thing to do first is do your protons and your electrons. So since it's number 2, it has 2 protons and 2 electrons. The positives and negatives have to cancel out. Then we look at the mass. The mass of helium is 4.002. Okay, so the nearest whole number would be 2. Just kidding. The nearest whole number would be 4. So since I have 2 protons, I also have to have 2 neutrons because the protons and the neutrons make up the mass. So this is what helium would look like. So on your paper, on your iPad, you want to write protons 2, electrons 2, neutrons 2, mass is 4 because it's 1, 2, 3, 4, protons plus neutrons. Alright, the next one is lithium. Lithium is atomic number 3. Okay, so it has 3 protons and 3 electrons. So the mass of lithium, it says it is 6.94. So the nearest whole number would be 7. Okay, so if I have 3 protons, I need to have 4 neutrons. Okay, because that's 1, 2, 3, 4, 5, 6, 7. Okay, protons and electrons are the same because the positive charge and negative charge have to cancel each other out, so the overall charge of the atom is 0, but the mass is 7 because 3 protons, 4 neutrons. Alright, next we have beryllium, which is atomic number 4. Okay, so I'm going to add 1 more proton, 1 more electron, so this is 4. And then the mass is 9.012. So if I have 4 protons, what 4 plus what equals 9? Oh, it's 5. Okay, so it's going to be 5 neutrons. Okay, so the red and the yellow add up to the mass. The red and the blue, protons, electrons, they cancel out, so the charge is 0. Okay, final, then we've got number 5, boron. So I know it has 5 protons, 5 electrons. So the atomic number is 5. The mass is 10.8. Okay, so I'm going to round that up to 11. And you may be wondering, why are there decimal points? Well, that is something that we are going to talk about later today. Alright, so it's got 5 protons, 5 electrons, and it has 6 neutrons because 11 minus 5 is 6. So if you count 6 plus 5, that's 11. Remember, protons and neutrons make up the mass. And then finally we've got carbon. Carbon is atomic number 6, so it's going to have 6 protons, 6 electrons, and the mass is 12.01. So it's got 6 protons, 6 electrons, and 6 neutrons. Okay? If you got confused or I talked too fast, feel free to go back. You can pause at any time when you need to draw a picture. If you didn't finish taking pictures during the activity or you were absent, you are more than welcome to come in seminar and do this, or you can just draw the picture with red protons, blue electrons, and yellow neutrons. Bye.